Notice that we're passing out a homework set for you guys, and I want to remind you of something or other. And you guys have asked me about it, and I set up something for you guys, and here it is. This is your home page, but remember to scroll down because that's where all the important information stuff is. And here's our pacing guide, and here is the actual link to what I'm passing out to you guys. So I'm actually giving you guys a gift by actually printing it out for you guys and billing the math department for it. So this is what I want. This is a homework set. You guys asked me, because you guys are concerned about you've done so much work on the computer, but you actually haven't done, besides the problems we've done in class, you haven't had your own homework kind of problems. And what am I going to actually what kind of questions I'm going to put on the test? Well, I'm handing you a homework set. Now, this is a large homework set. I think I got about 35 questions on this thing. Your test is going to be considerably shorter than this. Please understand that. But these are the style of questions I'm going to give you guys. I'll give you some multiple choice. There's also some pre-response questions on this thing. And this is the information that you need to know. If you know this stuff, you should be able to ace the test. If you don't know it, well, there's always next semester. So you've got to study this thing. This is what this homework set is for. I call this thing homework number 1, but test review number 1. This test review 1, this is covering that chapter 1 and chapter 2 stuff. So these are the questions that I'm covering on this stuff. And we're on Friday. It is due at the beginning of class on Friday, and I'm going to go over the whole thing with you guys, okay? To give you guys something to study over the weekend, because your test for you guys is on Monday. So, and again, for those folks that don't know, I also printed out, if you go to your pacing guide schedule, which is, I put it right up here, you click on it, we're actually right on schedule at this point. Today, February 4th, I'm covering section 2.5A, which is more on limits, and then we're going to do on Wednesday, 2.5B, continuity. Friday, we are doing our review, chapter 1, 2 review. This is the thing, the handout that I'm giving you guys, but it is homework. You have to turn it in. You got to turn it in the beginning class on Friday, and you'll give it to Saunders. So, which means I want you guys to make 2 copies of this thing. I just gave you guys 1 copy. This is the copy I want you guys to turn in. I want you to come to class with a blank copy as well, and we'll work through this entire thing and give you guys an idea of, what was I looking for? I was expecting it, and I'm going to show you, 35 questions, you can still do it in 50 minutes or less if you know what you're doing and stuff. So, and of course, I'm going to record it so you guys can watch it all weekend long and get prepared for your test, because your test is on Monday. Does that make sense? All right. So that's the big deal. So you will be printing out another copy of this thing to bring with you on Friday, because you got to have something to write over, because you're going to turn the one I just gave you guys back to us on Friday at the beginning of class, and then I'm going to, like I said, go over this whole thing, and that's going to be my big lecture for Friday's class. So there we go. All right. So today, according to our syllabus, we're supposed to go over more about limits. Now, we already know quite a bit about limits and stuff, so we're just going to be kind of expanding that and try to get you guys more into the mindset. But we're going to add one more kind of limit to you guys. So right now, when it comes to limits, I want you guys to remind yourself there are 3 rules when it comes to limits. The 3 rules for limits are, I'm going to write these things down for you guys. So here it is about limits. First rule. Rules. Number 1. What's the first thing you do with the limits? Plug in a number. Plug in a number. And if you get a number, that is the limit. First rule of limits, plug in a number. Get a number, you're done. That's the answer. Okay? Number 2, plug in a number, and if you get the number divided by 0, and this is a full limit, not a one-sided limit. So we're talking about a full limit here. not one-sided. Then the answer is DNE. What does DNE stand for? Does not exist. And the reason for that is officially you're getting an infinity style answer, but our definition of a full limit, that's with that little plus or minus thing there. The definition of full limit is you've got to go to a number. Infinity is not a number, it's an idea. The biggest number you can think of, +1, or negative infinity, the smallest number you can think of, -1. Number you never really get to. Since it's not a number, we say the limit does not exist. So when I plug it in, I get a number divided by 0, it's straight up. Now, if it's a one-sided limit, you need to do a little t-bar, because you are, with one-sided limits, allowed to have an infinity or minus infinity answer, and it's going to be one of those. You just have to figure out which one it's going to be by literally plugging it in very, very close to that. And then the third case here is plug in number. And if you get the famous 0 over 0 indeterminate form, what are you supposed to do? Then do my famous word, algebra. Typically factor, clean up something or other. Something should cancel on that thing. 0 divided by 0. The ultimate goal, hopefully, something's going to cancel. But the only way it's going to cancel is through strict multiplication division, which means you need to factor, simplify, something like that. Do algebra, cancel, and then plug in the number for the limit value. And that's what we've been working on with all this limit stuff. Okay? Now, there's going to be a fourth one here. We'll talk about that one in just a second. But these are your classic ones for this limit as x approaches a of some function f of x. This is the model that we're actually focusing on this one. All right? So, these are properties of limits. So, here it is in terms of some of the formulas and stuff like that. And honestly, the best way to describe this is properties of limits. So, it says this. Suppose that c is any constant, and n is a positive integer, and a is a real number, and we're taking the limit as x approaches a of f of x equals L1, and the limit as x approaches a of g of x is equal to L2, where L1 and L2 are obviously real numbers. They're limit values. Complete the following list of properties. Number 1. Take the limit as x approaches a of c. C is an arbitrary constant. First limits is plug in a number. Problem is, there's no x to plug into. And since there's no x to plug into, when you take the limit as x approaches any number of a constant, you know what you're going to get? Just the constant. There's nothing to plug into, so if you take the limit as x approaches 27 of 5, you get 5, because there's nothing to plug into. You just get the value, 5. Okay? Now, number 2 here, if you take the limit as x approaches a of just x, first rule of limits is plug in. Now this time, x is going to a, so when I plug in a for x, I actually get a. And of course, the limit as x approaches a of x to the n, I'm going to plug in for plug in for x, a, and I'm going to get a to the n. First rule of limits, plug it in. Number 1, there was nothing to plug into, so you just get a constant. Number 2, when I plug in x as a, I'm just going to get a. And number 3, when I plug in x as a, I get a to the n. Now, according to the third one, this is your property when it comes to limits of sums and differences. When I take the limit as x approaches a of f of x plus or minus g of x, that's the same thing as the limit as x approaches a of f of x plus or minus the limit as x approaches a of g of x. In other words, when you're taking the limit of functions that are being added or subtracted, you take that limit and you go after where those variables are located at. You're going after, in this case, the x's. Okay? And since we were told up here, the limit as x approaches a of f of x is L1, the limit as x approaches a of g of x is L2, this is the same thing as L1 plus or minus L2. Similarly, if I happen to have a product of two functions, take the limit as x approaches a of f of x times g of x. Well, that's the same thing as you take that limit and go after where those functions are located at. That'll be the same thing as the limit as x approaches a of f of x times the limit as x approaches a of g of x. And now we know what these values are. This will be equal to L1 times L2. Now, this is your properties. If I've got some kind of interesting function, I take that limit and plug it wherever those variables are located at. And the same idea when it comes to division. If I got the limit as x approaches a of f of x divided by g of x, that's the same thing as the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. Which, since the limit as x approaches a of f of x is equal to L1, and the limit as x approaches a of g of x is L2, you're going to get the resultant L1 divided by L2, provided L2 is not 0, because you can't divide by 0. This next one, the limit as x approaches a of c times f of x. Well, just like with those derivatives, because remember the definition derivative was a limit definition, constants held over and went out front. Same idea with limits. So if I'm taking the limit as x approaches a of a constant times a function, that's the same thing as that constant times the limit as x approaches a of that function. And we were given the limit as x approaches a of f of x is L1, so this would be actually the constant times L1. And same idea when it comes to powers or radicals. The limit as x approaches a of the nth root of f of x. You take that limit and go where that function is located at. That's going to be the nth root of the limit as x approaches a of f of x. But that part is L1, so that's the same thing as the nth root of L1. But I just want to remind you, a radical is a fraction of a power. So the nth root of L1 is the same thing as L1 to the 1 over n power, if you want to write it like that, where L1 to the 1 over n power is defined. So this has to be defined. You can't take that even root of a negative number or something like that. Square root of negative 4 officially does not exist. Now, first rule of limits, plug it in. And you're going to see a lot of this. So if p is a polynomial function, then the limit as x approaches a of p of x is equal to what? First rule of limits. What are you going to do? Plug it in. I'm going to replace x with a in p of x. What am I going to get? This will be equal to p of a. Does that make sense? Literally just replace the x with a, and whatever value you get will be the solution. Does that make sense? So on your first test, you're going to see lots of limit depth problems, and you're going to see lots of derivative problems, slopes of the tangent lines and the equations thereof and stuff. Now, here's the number 2. Here's the new guy. Now, over here, we talked about the indeterminate form of 0 divided by 0, okay? And we were supposed to do algebra on this thing. Well, here comes a special case here. It is also known as indeterminate form, and that is the limit, if you take the limit as x approaches infinity, this is the new guy, of some kind of polynomial over polynomial, p of x over q of x. And you get infinity over infinity, and honestly, it doesn't matter if it's plus or minus, infinity is there. This is called an indeterminate form. Now, honestly, there's lots of different kinds of indeterminate forms, but the ones that we focus on in indeterminate forms are going to be 0 over 0 and infinity over infinity. Because infinity over infinity, what's the answer? Well, since the numerator is infinity, does that mean the answer is infinity? Well, since the denominator is infinity, does that mean it's going to go to 0? Does it cancel and you get 1? Well, yeah, sometimes you get one of each of the above. I can give you examples of each one of those type of cases. So there's more than one way of looking at an answer. That's why we call it an indeterminate form. Okay? Now, here's the idea before we move on to the next page here. All right, so let me show you, and remind you guys what's going on. So this is going to be my special case that I'm talking about down here. So here comes number 4 on the limits. This is the special case. And what we're doing here is we're taking the limit as x approaches infinity of f of x divided by g of x. This is that special case that we're looking at, okay? First off, there are rules on this taking the limit as x approaches infinity. The first rule is this. What is the limit as x approaches infinity of 1 over x? First rule of limits is to plug in the number. So, but this time x is going to infinity. So if I plug in infinity, I'm going to get 1 over infinity. The question is, what is 1 over infinity? And it is a pattern that you catch, and so this is a definition. Well, x is getting really, really big. So 1 over really, really big. So 1 over 1,000 is 1,000. 1 over 10,000 is 10,000. 1 over 1,000,000 is 1,000,000. 1 over 1,000,000,000 is 1,000,000,000. It's getting microscopically small, and it's going towards what number when you go 1 over something really big? No, not negative infinity. That would be negative. These are all positive. See, 1 over 1,000 is 1,000. That's 0.001. 1 over 10,000 is 10,000, 0.0001. So what number is it getting really, really close to? It's getting really, really close to 0 because they're all positive. You have to switch to the negative side. Does that make sense? So here's an idea, and it's a very important idea. 1 over infinity goes to 0. This is going to be one of my tricks. And it doesn't matter whether you're going to positive infinity or you to go to negative infinity. Limit as x approaches negative infinity of 1 over x is 1 over negative infinity. And that's the same idea. It's 1 over negative 10,000, which makes it negative 10,000th. It's going to 0, but it's on the negative side, but it's still going to 0. So whether it's plus or minus infinity, when the infinity is in the denominator, a number over infinity, it's going to go to 0. Okay? So we have a rule. Combine this to be a rule. When you take the limit as x approaches either plus or minus infinity of 1 over x to p, p is a positive power. You're going to get 0. 1 over infinity to a positive power. Infinity to a positive power is going to be infinity. But 1 over infinity is 0. Does that make sense? And it doesn't matter if I'm on the negative side or the positive side. It doesn't matter. They're both going to go to 0. This is just a positive power here. Okay? Yeah. What's 2 times 0? Right. You can hold the 2 out front, and you still got 1 over infinity. So the question was, what about 2 over infinity? All right? 2 is a constant. So hold them out front. So it's 2 times 1 over infinity. But 1 over infinity was what? 0. And so 2 times 0 is 0. It don't matter what the numerator is. Unless it's infinity. Okay? Infinity over infinity, that's back to that. I can't tell you what's going on. But if the top numerator remains the same, but the denominator gets bigger and bigger and bigger and bigger, it's going to go to 0. Okay? It doesn't matter. 1 is our standard constant. It can be any constant number. The infinity over infinity, we're going to have a trick. Okay? And the trick is actually this. If I give you a problem like this, and the best way to describe the trick is to talk about it, I want you guys to take the limit as x approaches infinity of 2x squared plus 5x minus 1 divided by 4x squared plus 6x plus 12. All right. If you plug an infinity on this thing, you get some weird numbers like infinity squared, which is really big infinity, times 2 is still infinity, 5 times infinity, infinity, infinity plus infinity is infinity, minus 1, still infinity. Infinity squared is infinity, times 4 is really big infinity, 6 times infinity is infinity, infinity plus infinity, plus 12, still infinity. What this really is the famous infinity over infinity indeterminate form case, if you plug an infinity. Now, I'm going to show you guys how to look at this problem and tell what the answer is, but you still got to show me the work. This is how you show the work. It is a trick. The trick is to note the degree of the denominator. What is the degree of the denominator? Deno is my code for denominator. Now we're talking about polynomials over polynomials. These are rational functions. The degree of the denominator is 2, right? So the degree of the denominator is 2. So what you're going to do with a problem like this is you're going to multiply both the numerator and denominator by 1 over x to the degree of the denominator. What was the degree of the denominator? 2. So you can multiply both the numerator and denominator by 1 over x squared. And you look at this thing, well, trust me, this is the algebra and showing the answer. It's the degree of the denominator, and you'll multiply both the numerator and denominator by 1 over x to that power, in this case 2. Okay? Now, why do you want to do this? Because now you're going to distribute. And we're going to do this rather quickly because it's easy math. This is the limit as x approaches infinity of, here we go. What is 2x squared times 1 over x squared? What happened to the x squareds? They're going to cancel. What are you left with? 2. 2x squared divided by x squared. In your head, the x squareds cancel. You're left with 2. Plus, what is 5x times 1 over x squared? Well, it's 5x over x squared, but you can reduce the x and the x squared. X goes in the x squared how many times? 1 time. See what you're left with? 5 over just x. One of them canceled. You had an x squared down here, but one of them canceled. The last one is minus 1 times 1 over x squared. You can multiply that. That's minus 1 over x squared. Now I'm going to distribute through the denominator. What is 4x squared times 1 over x squared? Just 4, because the x squared cancel, right? What is 6x times 1 over x squared? Plus 6 over x, because one of the x's canceled, but one's still there. And then plus 12 times 1 over x squared is 12 over x squared. You remember all those limit properties we did? Now this is a mental case of using the limit properties. You take that limit and go after wherever the variable happens to be located at. So now, look at this guy here. I got a bunch of variables. I got 2 plus 5 over x variable minus 1 over x squared variable divided by 4 plus 6 over x variable plus 12 over x squared variable. But thanks to this property up here, when I take the limit as x either approaches positive or negative infinity of 1 over any x to a positive power, what do those terms always go to? 0. And it doesn't matter what the numerator is. So it's 5 times 0, which is still 0. Anytime you're taking the limit as x approaches either plus or minus infinity of x in the denominator to a positive power, these guys are going to get bigger. The infinities go to bigger, but the fraction gets smaller and smaller and smaller. These guys go to 0. That's part of this property here. And this shows you my work so I can get the answer. What's left in the numerator? 2 plus 0 minus 0 there. What's left in the denominator? 4 plus 0, which is 4. And of course, reduce your fractions. 2/4 is also known as 1/2. And that is the resultant. The limit as x approaches infinity of 2x squared plus 5x minus 1 over 4x squared plus 6x plus 12 is actually 1/2. Okay. So, getting back to our notes and stuff here, turn the page on this thing. This is the property. So that's one good example there, but I'll do more. All right, so look at these questions here. It says this, a blank blank is a function of the form of f of x equals p of x over q of x, where p of x and q of x are polynomials. Well, if you heard my words a few seconds ago, you know the name of a polynomial divided by a polynomial. That's called a rational function. Polynomial over polynomial rational function. Some teachers call them fractional functions. Yeah, okay, fine, but the fancy and the correct terminology is called a rational function. And as we were just mentioning a few seconds ago, what is the limit as x approaches positive infinity of 1 over x? 0. What is the limit as x approaches negative infinity of 1 over x? Doesn't matter if it's plus or minus infinity. When the infinities are in the denominator, a number divided by infinity, those fractions go to 0. That's what this section's about with this more concept of limits here. Now, here's a special case. This guy right here has actually something called the horizontal asymptote theorem. Horizontal asymptote theorem is what you discovered. You've seen this guy before in your high school algebra 2 class, college algebra, whatever you guys call it, math 3 or whatever. All right? And there's a trick to this problem. So, here's the deal. And this is the pattern, catching a pattern. I told you guys I can look at these problems and tell you what the answer is. I'm about to show you guys how to do the same thing. Okay? Here's the deal. See this problem right here? What you've got here is f of x equals a sub n x to the n plus a n minus 1 x to the n minus 1 plus dot dot plus a0 divided by b sub m x to the m plus b m minus 1 x to the n minus 1 plus dot 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 plus b0. Officially, if you remember your notation, this is that, quote, polynomial divided by polynomial, where the degree of the numerator is n and the degree of the denominator is m. Okay? And a sub n is called the leading coefficient of the numerator, and b sub m is the leading coefficient of the denominator polynomial. Now, if m equals n, in English that would be the degree of the numerator top is equal to the degree of the bottom denominator. Okay? If the degree of the numerator is equal to the degree of the denominator. Here's what the answer is every time you take the limit as x approaches, it doesn't matter, plus or minus infinity, okay, of this particular function. You're going to get a sub n over b sub n. When the degree of the top equals the degree of the bottom, and this is what we call the ratio of leading coefficients. COEF, coefficients. Ratio of leading coefficients. You remember this problem I just did a few seconds ago? Here, forget the rest of this stuff I just wrote down. Here's the problem right here. What is the limit as x approaches infinity of 2x squared plus 5x minus 1 divided by 4x squared plus 6x plus 12? What's the degree of the numerator? No, degree. 2. What is the degree of the denominator? 2. Degree of the numerator, 2, equals degree of the denominator, 2. According to this theorem, called the horizontal asymptote theorem, the limit is going to be the ratio of the leading coefficients. What's the leading coefficient of the numerator? 2. What's the leading coefficient of the denominator? 4. And that's what we wrote, 2 over 4, which is equal to 1/2 when you reduce it. So you can look at this problem and tell you what the answer is going to be. That's nice when it comes to math. It's always impressive when you work with somebody and go, oh, clearly the answer is going to be 1/2. Now you know why the answer is going to be 1/2, because it's actually a theorem. They don't actually explain it to yourself. But, as I mentioned to you guys, this is math class. I'm showing you guys how to look at the problem and tell what the answer is. But, we do expect you to, on free response problem, show me the work. This is how you show the answer is going to work. This method of multiplying by 1 over x to the degree of the denominator, distributing, cleaning up will work every time. So that being the case, here we go. For part 2 on this one here, for m being greater than n, then the limit as x approaches plus or minus infinity of f of x is going to be what? Now, here's the deal. Let me just say, degree of the top is actually less than the degree of the bottom, or the degree of the bottom is bigger than the top. However you want to look at that. When the degree of the bottom is bigger, the answer is going to be 0 every time. Because everybody's going to cancel out in the numerator, and you're still left with 5 in the denominator, or some kind of number. And a number divided by 5, or whatever constant you got, is always going to be 0. And then in the last case, when the degree of the top is strictly greater than the degree of the bottom, when you take the limit as x approaches plus or minus infinity of f of x, you're going to get either infinity or negative infinity, and you actually have to do the algebra to figure it out, and that's that 1 over x to the power. So right now I'm basically telling you, you got a 50-50 shot. Is it infinity or is it negative infinity? It's going to be one of those two. Which one? I don't know. It depends on what the constants are in the problem. I have to kind of follow my signs, but I can figure it out from that. So it's three cases in terms of this limit as x approaches infinity. And what this little section's all about is these kind of problems here, okay? So, but most important is I want you to look at this problem and how we did it. This is showing the algebra of this problem, okay? And if you go back and look at this guy here, remember what we said in number 2. Now, I didn't actually emphasize this, and now I am. When you take the limit as x approaches infinity, or plus or minus infinity, doesn't matter which one, a p of x over a q of x, you get infinity over infinity called indeterminate form. To determine what the limit is, if it exists, divide each term by the highest power of x. That's multiply 1 over x to the denominator. That's going to be the trick. That's the hint that they're trying to give you guys to show you this. So take a look at this particular problem here. Now, here's the deal. There's actually 2 problems on this one, and we only wrote one of them up for you, so I'm going to write 2 of them here. This is the limit as x approaches infinity of x squared minus x minus 2 over x squared minus 4. Now, the reason why I'm writing 2 different problems is because I want you to pay attention. That's where people are going to die in this class because you weren't paying attention to the problem. Look at the numbers, they make a difference. This first problem, take the limit as x approaches 2 of x squared minus x minus 2 over x squared minus 4. This is a regular limit because you're approaching a number. What's the first rule of limits? What you going to do? Plug it in. So this is equal to 2 squared minus 2 minus 2 over 2 squared minus 4. Well, 2 squared is 4, minus 2 is 0. 2 squared is 4, minus 4 is 0. What am I supposed to do in the famous 0 over 0 indeterminate form? We're going to do algebra. I'm going to try to factor or cancel something out. Now, in terms of this one, obviously would be factoring. So this would be equal to the limit as x approaches 2 of, how does your numerator factor? X squared minus x minus 2. X squared is going to factor x. 2 is going to factor 2 and 1. And because it's minus, they're going to have opposite signs. Since the middle term is negative, a minus on the 2, plus on the 1. How about that x squared minus 4? That also factors. That's called a difference of squares. How does that factor? X plus 2 times x minus 2. Same numbers, opposite signs. Now, strict multiplication division, somebody cancels here. What cancels in these terms? X minus 2. So this is equal to the limit as x approaches 2 of x plus 1 divided by x plus 2. That's the result. And then, after I cancel, what do? Plug it in again. This will be 2 plus 1 over 2 plus 2. That's 3 over 4. Yeah, the answer is 3/4. Does that make sense? But pay attention. See, we switched the problems up on you. So now, take a look at the next guy. Take the limit as x approaches infinity of same function, x squared minus x minus 2 divided by x squared minus 4. Okay? Well, this is an infinity problem. And how do I do an infinity problem? You are going to multiply by 1 over x to both the numerator and denominator, so it's a ratio of 1, so it doesn't change the problem. 1 over x to the degree of the denominator. What is the degree of the denominator? 2. So you multiply both the numerator and denominator by 1 over x squared. It's because of that 2 right there. Does that make sense? I'm going to distribute that and clean it up as I go. So this would be equal to the limit as x approaches infinity of x squared times 1 over x squared is 1, because the x squared is canceled, minus x times 1 over x squared, x divided by x squared, one of the x's cancels, you're left with just 1 over x, minus 2 times 1 over x squared is actually minus 2 over x squared, nothing canceled there, divided by, now distribute the 1 over x squared through the denominator. X squared times 1 over x squared is a 1, minus 4 times 1 over x squared is 4 over x squared. Now, applying that limit property about when the infinities are in the denominator. Again, we're replacing all the x's with infinities, but when the infinities are in the denominator, the fractions go to what? 0. So that's our property, that 1 over infinity is 0, so this will go to 0, this will go to 0, this will go to 0. What are you left with? 1 divided by 1, which makes the answer 1. Two totally different answers here, but two totally different processes. We're going to two different limits. This limit as x approaches a number a, 2. This limit as x approaches infinity. So two different approaches for a similar function there. Does that make sense? But yeah, I could have told you what the answer was before we started. Look at this problem right here. What is the degree of the numerator? Degree. What's the question? What's the degree of the numerator? 2. What's the degree of the denominator? 2. They're equal, so the answer is the ratio of leading coefficient. The leading coefficient in front of the x squared is a 1. The coefficient in front of the x squared in the denominator is a 1. The answer is 1 over 1, which is 1. I can look at it and tell you what the answer is. Does that make sense? All right. So now let's use some of those limit properties that we were talking about, and let's do these problems here. What is the limit as x approaches 61 of 97? There's just numbers here, but first here. Take the limit means I'm going to get basic first row limits. I'm going to plug in the number. Every time I see an x, I'm going to plug in a 61. You see an x in this problem? No, all I see is 97. So there's nothing to plug into. So what's the answer? 97. It doesn't get much easier than that. There's nothing to plug into. Just write it down again. The answer is 97. Take a look at the next guy. Take the limit as x approaches 1/2 of 7x plus 1 divided by 10x plus 8. First rule of limits, what you going to do? Plug it in. Yes, it's a fraction, that's great, but still, first rule of limits, plug it in. So this is going to end up being 7 times 1/2 plus 1 divided by 10 times 1/2 plus 18. All right, well, let's see what we got here. What's 7 times 1/2? Exactly. 7 halves plus 1. 10 times 1/2 is what? 5 plus 18. So I get 7 halves plus 1. Well, 1 is 2 halves. 2 halves plus 7 halves is 9 halves divided by 5 plus 18. How much is that? Don't hurt yourself. 5 plus 18. I think 23. All right. And then, well, I'm going to stick him over 1 to make him a fraction, because when I have a fraction divided by a fraction, how do I clean that up? Well, invert multiply by the reciprocal. So you end up getting 9 halves times 1 over 23. And the answer, 1 times 9 is 9. 2 times 23 is what, 46? Yeah, crappy number, but that's the answer. The answer is 9 over 46. First rule of limits, plug it in, and you just got to crunch it out. Does that make sense? Next one, we're going to make you start thinking now. It's a trick. I'm going to show you the trick. So remember this, and again, special tricks, right? Put those little words on it. I'm going to take the limit as x approaches 100 of the square root of x minus 10 divided by x minus 100. First rule of limits, what you going to do? Plug it in. This will be the square root of 100 minus 10 divided by 100 minus 100. What's the square root of 100? 10. 10 minus 10 is 0. 100 minus 100 is 0. It's 0 over 0. So with 0 over 0, what am I supposed to do? Do algebra. Here's the algebra. This is what I'm talking about, the trick. You've got to look at him in the right way. So this will be equal to the limit as x approaches 100 of that numerator, square root of x minus 10. I'm going to leave him alone. Now, look, I've got a square root in this problem, okay? So the way you need to look at this, and look, I have an x in the denominator. What exactly is x? X is the same thing as the square root of x squared. When you square a square root, what happens to it? They cancel, you're left with x minus 100. So because this is the square root of x squared, and actually 100 is actually, think about it, it is 10 squared, right? It is what we call a difference of squares. And just to remind you, when you got a difference of squares, a squared minus b squared, that always factors into a plus b times a minus b. You with me? Difference of squares. They're not your traditional, well, what is x squared minus 9? Yeah, it's x plus 3 times x minus 3. This is the square root of x squared minus 10 squared. You can still look at it as somebody squared minus somebody squared. So this will be equal to the limit as x approaches 100. Keep the numerator along, that'll be square root of x minus 10. But the denominator can factor over the difference of squares pattern. But what's inside the parentheses is the square root of x. So what's x actually? It's the square root of x times the square root of x. What times what's 100? It's 10 and 10. It's a difference of squares, so one's plus, one's minus. Does that make sense? You just had to look at them in the right way. That's the trick. What cancels here? The square root of x minus 10's cancel. You're left with, and I'll continue writing limit until you actually plug in the number. Take the limit as x approaches 100 of 1, once everybody cancels, it's got one replacement, divided by the square root of x plus 10. So again, rule limits, plug in a number. This is going to be equal to 1 over the square root of 100 plus 10. Now, I did that for your benefit because I want you to see, once I clean it up, I plug in the number. And when I plug in the number, I don't write limit anymore. Now let's just crunch it out. What's the square root of 100? 10. So what is 10 plus 10? So the answer is 1 over 20. Does that make sense? But you had to look at him as a difference of squares. And that's a special kind of when you see x minus 100 or x minus 9, you can factor that as a square root of x plus 3 or square root of x minus 3. You can still look at him as a difference of squares. So there's the trick on that one. This one right here, take a look at it. Take the limit as x approaches 4 of x squared minus 16 divided by x squared minus 9 plus 20. First rule of limits, what you going to do? Plug it in. Plugging in 4 squared minus 16 over 4 squared minus 9 times 4 plus 20. 4 squared is 16, minus 16 is 0. 4 squared is 16. 4 times 9 is 36, plus 20. 16 plus 20 is 36, minus 36, yep, it's 0. Does that make sense? So, it's 0 over 0 case of indeterminate form, so I'm going to do algebra by factoring this guy. So this is equal to the limit as x approaches 4 of, how would you factor x squared minus 16? That's a traditional difference of squares of x plus 4 times x minus 4. How does x squared minus 9x plus 20 going to factor? Well, it's x squared, so it's x and x. What times what is 20? Because it's a plus, that's going to add up to be 9. 5 and 4, and because it's a plus, they have the same sign. Since the middle terms are minus, they'll both have minus signs. And you can clearly see now that the x minus 4 in the numerator and denominator being multiplied and divided are going to cancel. So you're left with the limit as x approaches 4 of x plus 4 divided by x minus 5. And now, what you going to do now? Plug it in. This gives you 4 plus 4 over 4 minus 5. 4 plus 4 is 8. 4 minus 5 is negative 1. The answer is negative 8. And again, I am really trying to demonstrate to you guys the work that we want to see on this stuff. Look at the next guy. I want you to take the limit as x approaches negative infinity of x cubed plus 27 divided by x squared minus 3x plus 9. What is this? First off, pay attention. It's an infinity. In your case, it's negative infinity, but it's infinity, which means I'm going to do the 1 over the degree of the denominator trick, because this guy's the special case here, case number 4 with limits. What is the degree of the denominator? 2. It is this guy right here, degree of the denominator. So you're going to multiply by 1 over x squared in the numerator and 1 over x squared in the denominator. Does that make sense? And I'm going to distribute. This will be equal to the limit as x approaches negative infinity, and then I'm going to distribute here. X cubed times 1 over x squared is just x. 27 divided by x plus 27 divided by x squared, because nothing cancels. Divided by x squared times 1 over x squared is 1. Minus 3x times 1 over x squared. X goes in x squared x times, that'll be minus 3 over x. Plus 9 times 1 over x squared is 9 over x squared. Does that make sense so far? Now watch this. When I take the limit as x approaches positive or negative infinity, my little fractions with x in the denominator all go to what? 0. This goes to 0, this goes to 0, this goes to 0. But you're left with an x left over, so keep writing it. This will be the limit as x approaches negative infinity of x over 1. Now plug in your infinity. This will be negative infinity divided by divided by positive 1. What is negative infinity divided by positive 1? Negative infinity. And if you go back and look at it, what was the degree of the numerator? 3. What's the degree of the denominator? When the degree of the top is bigger than the bottom, you're either going to get plus or minus infinity. I don't know which one until I work it out. If that happened to be a negative 1 in the bottom, negative infinity divided by negative 1 would have been a positive infinity. So you understand you actually have to work the math out to see what the sign's going to be, but it would be an infinity case. Last problem here. Take the limit as x approaches infinity of 4x squared plus 7x minus 9 over 5x squared plus 16x plus 2. Just stop. What's the degree of the numerator? What's the degree of the denominator? Degree of the top equals degree of the bottom. What's the answer to this problem? 4/5 ratio of leading coefficients. You got the answer. It's 4/5. But now, to show, to get full credit, oh, yeah, give me an answer. I just think you stole it off your neighbor's paper. I have no idea. I want to see the work on this thing. So to see the work, I'm going to multiply by 1 over x to the degree of the denominator. The degree of the denominator is 2. So multiply by both the numerator and denominator by 1 over x squared. And I'm going to distribute. So this will be equal to the limit as x approaches infinity of 4x squared times 1 over x squared is 4, plus 7x times 1 over x squared is 7 over x, minus 9 over x squared. 5x squared times 1 over x squared is 5. 16x times 1 over x squared is plus 16 over x. And 2 over x squared is plus 2 over x squared. Now take your limit as x approaches infinity. All my little fractions with x's in the denominator go to 0. And you're left with 4 plus 0 minus 0 divided by 5 plus 0 plus 0, which makes the answer 4/5, which is exactly what you told me it was going to be. Does that make sense? Well, we only got one more section, and please, go ahead and start this homework set that I passed out to you now. It is due on Friday at the beginning of class. Make another copy of this thing. I just provided you a copy of it. That's the one I want you to turn in. Make another copy of it so you got this stuff to take notes off of, to study over the weekend of. But remember, this is going to be longer than your test. It's 35 questions. I'm looking at, honestly, around 20 questions for your test or so. Just keep that in mind. Study hard, and I'll see you guys on Wednesday.